This is the homework helper for Chapter 11, Section 3 in the 8th grade workbook, Solving Equations with Variables on Both Sides. So we're going to go ahead and take a look at a few of the problems here from the top in the 1 through 12 section. As you can see, in all of these questions, you are solving for the variable. There's nothing different about any of these questions in that regard. You're solving for the variable that's given on each one. Let's quickly review. As we solve equations, we want to go ahead and send all of our variable things to the left side of the equal sign. We want to go ahead and send all of our numbers to the right side of the equal sign. If at any point we should feel the need, we can invert the left and the right side, which is something we generally do when we have more things on the wrong spot initially than we do right. We can, whenever we want to move something to the opposite side of the equal sign, we do the opposite. Because most of these will end up looking like two-step equations at one point or other. We also want to remember that the thing that's directly connected to the variable, once we get some simplification done, will be the last thing to go. The thing that's not directly connected to the variable by multiplication or division always goes first. So with that all said here, let's go ahead and start with number 3. Number 3 says 4t plus 14 equals 6t over 5 plus 7. Now as you can see, we've got a fraction in there. Because we've got a fraction in there, we know from what we did the other day, we probably want to go ahead and fix that issue first. So I'm going to go ahead and fix the fraction problem here and then continue from there. Since this fraction has a denominator of 5, what I'm going to do is go ahead and multiply the whole line by 5. Because by multiplying by 5, it will cancel this out with the denominator and at least get rid of the fractions. What you have to remember, though, as you saw the other day, though, is you have to multiply every piece by 5. So this one, we've already done it with the canceling, but these other 3 terms also have to get a 5 factor multiplied into them. So 4 times 5 is going to change that one into 20t. 14 times 5 is going to change into 70. This, as we said, is just going to be 6t. That was the whole purpose. 7 times 5 here is going to change into 35. And now that I've taken care of the multiplying by 5, now it looks pretty much just like a standard little question. We're going to send our variables to the left and our numbers to the right. So I see 6t here, it's on the right, but again, variable things should go to the left. Again, when I want to move something to the opposite side of the equal sign, I do that by doing the opposite. So I'm going to go ahead and subtract 6t from both sides, which will get half of the job done. The other thing I need to do is move the 70. Again, numbers to the right, while 35 is already over there, 70's got to get over there as well. Since 70 has an addition sign in front of it, I'm going to go ahead and subtract. So I'm subtracting 70 from both sides here. Alright, so if I simplify this down to what I have now, I have 14t over here from 20t minus 6t, and I've got 35 minus 70 over there, which is negative 35. Alright, now, it's a multiplication equation, so I'm going to solve this by division, dividing by 14. Now, some of you might be looking at that and saying, well, 14 doesn't go into 35. Isn't that going to be nasty? No, because I'm just going to leave it a fraction. I'm going to leave it negative 35 over 14 and say I'm done. There's nothing wrong with that answer. You can reduce it. You could chop 7 out and write it as 5 over 2, negative 5 over 2 in this case, but it doesn't impact anything. Whether or not I actually reduce it, change it to decimal, I don't need to do that. That's extra work that's not required here. There's nothing wrong with the answer of negative 35 over 14. But again, if you want to write it as negative 5 over 2, if you want to go ahead and write it as negative 2.5, you're welcome to do that as well. And as you can see, looking at 4 and 5, you have fractions there as well that you need to deal with. Now, as we get into 6 and 7 and 9 and 10, those are distributive property questions. Distributive property, again, is when you take the number that's in front of the parentheses, multiply it through to the things that's inside the parentheses, and then we'll do all of our steps that we've just done. So let's go ahead and do that here in question 7. I've got 2 in front of the 5y plus 6. So I've got to go ahead and multiply the 2 through to the 5y plus 6 part to take care of the distributive property. So when I do that, that's going to give me 10y equals, or 10y plus 12 rather. 2 times the 5y, 2 times 5 is 10, and then 2 through to the 6, 2 times 6 is 12. Alright, so let's go ahead and simplify that now. I'm going to send my variables to the left and the numbers to the right here. So that means this 10y is going to be fed over here to the 15y because that's going to gather my variables on the left. Remember, when I want to move something to the opposite side, I do the opposite. And that's why I'm subtracting 10y. There's no sign in front of this, but it is positive. The opposite of a positive is a negative. A negative looks like subtraction, which is why I'm subtracting 10y. With the 14 here, as far as moving the 14, again, doing the opposite. So I'm subtracting 14 from both sides. And so when I simplify what I have left, I have 5y equals negative 2. Right, multiplication equation, now that we can solve with division, dividing both sides by 5 here. When I do that, negative 2 divided by over 5, I can leave it just like that, or I can write it as negative 0.4. Either one is perfectly acceptable. If we go ahead and take a look at 12, 12 kind of looks like a fraction problem, but it's not really a pure fraction problem, so I want to make sure we take a look at this. You've got a couple different ways as how you can approach question 12. One of the things you can do is you can get rid of the fraction here simply by multiplying both sides by 3 right away here, which will in effect do distributive property. The other thing you can do here is put this over 1, and then it will look like a proportion, and you can cross multiply. Let's go ahead and put that over 1 and cross multiply just so we can say we've seen that. As I put this over 1, now it says 8 minus 3x over 1. So I'm going to multiply the diagonals like I was solving a proportion here. So on the one diagonal, I've got 2x minus 9 times 1. Well, that's great. 2x minus 9 times 1, anything times 1 doesn't change. So that's still 2x minus 9. On the other diagonal, with 8 minus 3x times 3, I'm going to take the 3 through to the 8 and the 3 through to the 3x. That's distributive property. If you want to see me write it out, that's how it's going to look. A number being multiplied through to a set of numbers in parentheses. We know what to do because we've done it, but we haven't done a question that was set up like a proportion. So I want to make sure you've seen that. 3 through to the 8 is going to give me 24. 3 through to the 3x is going to give me 9. So I've got 2x minus 9 equals 24 minus 9x. Now I want to go ahead and simplify. All right, so as far as simplifying goes, variables to the left, so I'm going to send 9x over to this left side, and numbers to the right, which means 9's got to come over here. Let's go ahead and do that. Add 9x to both sides. So that's going to give me 11x's. Again, remember, when I move something to the other side of the equal sign, I do the opposite. So if it's got addition in front of it, the opposite is to subtract. If it's got subtraction in front of it, the opposite is to add. If it's negative, the opposite is a positive. Positive looks like addition. Use that logic the whole way through. It'll never fail you. As far as the 9 goes, sending numbers off to the right, it's got a minus in front of it, so I'm going to do the opposite, which is to add. So I'm adding 9 to both sides. 24 and 9 goes together to make 33. If I have 11x equals 33, by dividing 11, I reveal that x equals 3 for question number 12. All right, I want to go ahead and take a look at a story problem with you now here. So we'll go ahead and scroll down and take a look at number 14. It says in question number 14, the square and the equilateral triangle have the same perimeter. Find the length of the sides of the triangle. All right, so the shape on the left is a square, and every side there is x plus 5. So I've got x plus 5 and x plus 5 and x plus 5 and x plus 5. So if I want to write an expression for the perimeter of the square, I have 4 x's here when I go all the way around, so that's going to be 4x. And I have 4 5's, which is of course going to make 20. So to go around the square, the perimeter is 4x plus 20. Now this guy over here on the right is an equilateral triangle. Remember, the word equilateral implies that all the sides are the same. So if this is 3x, this is also 3x, this is also 3x. So we put all that together, and that makes 9x. I got 3 x's. 3 x's plus 3 more x's plus 3 more x's makes 9 x's. Solve the equation for x. Realize that's not my solution, but it is what x is, because the question is asking me to find the length of the sides of the triangle. So once I find x, I have to plug it back in to figure out how long the sides of the triangle are. Well, let's solve this. As is, I would not solve this like this, because right now the only thing that's good about this 4x having a variable on the left. 9x, 20, both not good, so we're going to fix both of those by flipping the sides. As you can see, when I do that, now I say variables on the left and numbers on the right, and I have two things that are much better, 4x being the problem here. So as far as 4x, I'm going to subtract 4x from both sides. That gives me 5x equals 20, and as you've already figured out, that means x must equal 4. Alright, so if x equals 4, I'm going to come up here now and change x to the 4 to figure out how long each side of the triangle is. Of course, all the sides are the same because it's equilateral. So I've got 3 times 4, which is going to change it to 12. So each side of the triangle is 12 units long.